I'm Seth Henderson. A little bit about me. I'm a software developer by day and whatever else I am by night. I got into 3D printing about a year ago when I came home. Well, my wife went on a run, and I was on the internet unsupervised, and she gets back home. I'm like, Jessica, guess what? I just got a 3D printer, thinking she'd be all excited. And she's like, why didn't you talk to me about this? And that's how it started. The printer I got was a kit printer and 3D printing itself has a learning curve to it. It's not particularly easy. It's not like your 2D printer where you go to the store, put it on your desk, plug it in, and hit print. It's not easy that way. You have to kind of learn the ins and outs. The things that I'm doing in this talk, well, first of all, the best thing that you could do to learn 3D printing is really just getting a 3D printer. But that would make a really, really short talk. So what I'm going to be covering are things like this stuff, a bit of the history about where modern 3D printing came from, what the different types of 3D printers, and then most of this talk is going to be centered around one specific kind, which is the most consumer-friendly kind, which is the FDM. And yeah, and then towards the end, printing process and, recommendations of a couple printers, which will not be exhaustive. Okay, so the first thing that I think is important is considerations. So things that you should probably think about before investing money into getting a 3D printer and time. And some of them I've mentioned as learning curve. Also, one thing that, before that even, what do you want to do with your 3D printing? Are you like, do you like doing tabletop games like D&D where you want to make your own models? This can do it, but it will cost time and stuff. Like, do you want to just print things off, download models off the internet and print other people's stuff? And exclusively that, which is fine as long as that's enough of a reason for you to invest the time and money into this. Probably the biggest thing that I think is a consideration, once you get into it, is safety. Because with the kind of 3D printer that I use, the part that heats up the plastic gets up to, I print it on average at 215 degrees Celsius. By the way, 3D printing, pretty much everyone measures using metrics. Well, the metric system, it's not the imperial system. So if I say things in metrics, that's why, that's how they do it. And so among those safety factors, the cheaper the printer you get, the more likely it is to not have been sufficiently quality tested. So, which is okay as long as you're okay with it and you have plans to mitigate those things. So, with the RepRap project, RepRap stands for, what is it called? Replicating Rapid Prototyper. It was started by this guy, Adrian Boyer, forget the name. He is I think he's emeritus professor at a school, remember which one, in London somewhere, in the UK. And as the story goes, he wanted to, his school had a 3D printer back before it was common to have, before this project existed. And he looked inside and was like, I can do that. That's not mechanically complex. And once the patents expired on that printer, the project took off. The project really did break off. Like, one thing that I think is really cool about 3D printing is it is a really strong testament to open source and how successful it can be when done right. It was born in open source. People were sharing ideas back and forth. They went through this evolution period. The first RepRap printer that I think he had like all PhD, he had a PhD student do the first draft. And so the Darwin was born. Most 3D printers don't look like this today, and thank goodness. Yeah, so these are a few printers that are more recent that have come about because of this project. The one on the left is called the hang printer, which is limited by how high from the ceiling you can do it, and motors and laws of physics and stuff. So like that whole, I think this print was called the Tower of Babel, and they just printed it. The one on the right is called the Snappy. This one is relatively new. It's in the past 2 or 3 years. It's the mostly 3D printed 3D printer that is also self-replicating. Like this printer can print the parts that make it up for itself, minus the electronics and motors and things. Just really awesome. Which goes us to this point. So not all 3D printers are RepRap are like that. The ones that are RepRap are the FDM 3D printers, sometimes called FFF, which just fancy way of saying you melt plastic and draw pictures in layers. The main idea here is like you have your spool of filament, whatever material it is, you force it with gears through a superheated hotend, and then draw 2D layers. You go one layer at a time, build it up and up. This printing process has some really cool features. Like these, I brought some show to go with tail. These octopuses with their joints, they were printed this way because of how the layers work. If you look at a link, you can do that. You can cut this into layers and still have it support itself. And you know, you guys can look at these if you'd like. And then I also have these coasters, which are less interesting, but they're useful. Anyway, the main safety concern with FDM is, you know, fires. You have electronics that are heating things up. So the two parts that are hot on this are your bed that you print on. Sometimes you can print on a non-heated bed, but it limits the materials that you can print at easily. So the heat bed, which typically goes between, I don't know, 50 to 100 degrees Celsius. And then the nozzle, which the minimum you can print at for that is 170, you know, 250. You can go higher than this, but you need to make sure that the hot end, the part that is there, is completely metal and there's no plastic inside. And I'll talk a little bit more about that later. The next kind of 3D printing is SLA 3D printing, which I don't know what that word means, stereolithography apparatus. But basically, you take this resin, and it's liquid at first. You put it in this pit, and you use a laser, whether it's a screen that's UV light that prints at a certain pixel depth, or just a laser that points at a mirror and then shoots at specific parts. And it will harden the resin as your print comes out. It's kind of cool to watch. If you've ever seen a time lapse of this, it looks like somebody's just pulling, you know that old magician trick, the hat and the rabbit? Looks just like that. It's really cool. Its main safety concern is just the resin itself. The resin is toxic. You wear gloves, you wear goggles, you have breath on it. This also is typically and historically been much more expensive to print with. For example, resin will cost you more. The resin itself will cost you more than your spool of filament for FDM 3D printing. So which is why, you know, this one kind, however, is starting to take off. If you're going to do something like 3D printing miniatures, this will achieve a much higher resolution and a much finer detail, if that's kind of your goal. Typically, you can get small. There is a printer I saw that's about $200, has a really tiny print resolution, but if you're doing miniatures, that's perfect. The other part of it is the resin, after it comes out of the printer, is not cured. You need to put it in the sun, you need to wash it, then put it in the sun actually. You need to process it, which is again, you know, gloves, you don't want to breathe it, you know, anything. Then the last kind is SLS, selective laser sintering. This is not a home viable solution. It's very expensive. I think the cheapest one I saw was either $6,000 or $9,000 for just the printer. Its main safety concerns are it has this fine nylon powder, and that's how it prints. And it just melts the nylon powder into your shape. And also there's a chance it'll cause conflict because of how much you decided to spend on this thing. Its main advantage, if you think about the other printing styles, the SLS or SLA and the FDM, you can't print over nothing. You can't just, which is almost true. You can do small gaps and bridge small gaps, but you can't just, print an area that starts on nothing. With this, however, the way it works is it fills the chamber with powder at every layer. So the powder that is not melted will support every layer on top of it. So you can get fine details without having to also print support materials into it. Okay, so this is the part where we talk about the basics of the FDM printer's anatomy, like what it looks like, how it works, that sort of stuff. And basics, the parts I broke it into, you could probably break it into finer detail, is the frame of the printer and also the axes of printing. The extruder, the part that actually melts the plastic, how that works and whatnot. The print bed and the electronics that control the whole operation. This is probably the most common print design right now, the i3. Prusa himself, the guy who it was named after, he makes this 3D printer itself, but he's open source the design. There are plenty of knockoffs on the internet. Mine is a knockoff that costs less than $200, which I do not actually recommend everyone getting. And spoiler alert, this is one of my recommendations. His printer costs around $700 to $1,000. $1,000 if it's pre-assembled. If you get it in kit form, $750, or I think was the price I saw last. The way it works, if you see the dragon where it's sitting, that bed is your y-axis. It moves during the print. The print head moves left and right, and then all up and down on 2 motors. And that's the way the motion works. You'll see in some of these other frame designs, they all have X, Y, Z axes, but they all have different ways of doing it. For example, there are various cube designs. So this design particularly is on a website called Thingiverse. You can get the bill of materials and figure out, you can build these yourself. So the RepRap project has a wiki. You can list all the materials, source them yourself, and build them. This one is one that I have seen only a handful of kits for, but anyway, I digress. The main difference of this one is that the print head does not move up and down. It moves in the x-axis and the y-axis independently, and your print bed starts at the top and slowly drops during your print. Typically these have aluminum frames and they're very sturdy and make a lot less motion, which is good for your prints. And then this print you've seen the snappy, I've never seen anything like this. This one, the print head stays stationary, only moves in the z-axis up and down, and the print bed moves in the x and the y direction. It's so weird to watch when it prints. Anyway, so this one is one that I added last because I'm like, oh yeah, these exist. It's called a Delta printer, which its main thing is it has motors on each of those 3 rails. Delta, I think that has something to do with geometry and math. Anyway, they each move independently, and to move the print head where it needs to be, generally they have a circular base. They can achieve higher precision than the other styles. Those other styles that we covered are called Cartesian, which I think has something to do with the fact that it's a square and uses a grid system that's not a circle.
So if I remember correctly, delta is actually a reference to the Greek letter delta that is shaped like a triangle. And so it's a reference to the footprint being a triangular shape. because you have the rails at the 3 corners.
That makes more sense to me. I don't have a Delta printer, but yeah. I put this GIF in here to kind of show how it works, because it's not as straightforward for my brain to grasp, and I thought maybe others would like to see a little bit of motion to show how it controls itself, because it's completely different. Oh, one other point. These Delta 3D printers, because of their triangleness, they use more processing power. Most of the printers, the FDM Cartesian printers, they use an 8-bit board, an Arduino, as their control board, and it works just fine. But this requires more math, and typically that doesn't mean you can't run a Delta printer, it means it'll run slower than you might otherwise like. There are 32-bit boards though. Okay, the Hotend and the extruder. So this one, the basics again are you have filament and you push it through. The way it pushes through is you see that the gear, and the gear is next to what is called an idler. The spring pushes the lever arm into your filament, which pushes it into the gear and holds it in place. Then the gear pushes it through and goes through that. See that the aluminum block on it? That's called the heater block. You'll have a wire plugged in that just makes good contact and heats the block. That's all its purpose is. And you'll have another one, typically a thermistor, that tells you how hot it's gotten. Or not you, it tells the control board. The two parts of the extruder, we have the hot end, which is the bottom part, and then the cold end, which is the top part. We want to keep the cold end cold and the hot end hot. Typically people will put a fan directly on the extruder part so that it will so that you'll prevent heat from going back up into the system and help your filament melt consistently and go through. That's what it is. This style of extruder is called a direct drive extruder. Its main advantage, oh yeah, there are lots of kinds of filaments. Flexible filaments are a thing. You can make like your own phone case that's flexible. People have printed their own shoes, 3D printed their own shoes. You can find models on that on the internet if you want to print your own shoes. I don't know how well that will work out for you. But the direct drive has the advantage of handling the filament very tightly and confined, so it can get it from point A to point B, and that's why they work better with that. The main disadvantage is if you have a direct drive, if you have a kind where the print head moves, then you have a lot of extra weight that's being tossed around on the printer, which will cause vibrations in the frame. And those vibrations will show up in your print. That gnome, you can kind of see some ripples going through, like if you go top to bottom. My printer has an acrylic frame, which is very sturdy, but it's also very light and vibrates really well. The other style is called a Bowden, where you have the extruder. You still have the hot end and the cold end. It's just they're separated by a long tube. So you force the filament through the tube, through the extruder part, and then it gets to the hot end and melts it. The advantage of this is you have a lot less weight on the end. The disadvantage is when you are printing, if you jump between two parts that aren't supposed to have filament, it needs to do what's called a retract, because the filament's just going to keep going. And where that just means retraction, just the gear spins the other way and sucks it back in. With this style, the retractions are not as quick. There's a lot more distance to cover. And so they will result in stringing. There are tests for this where you just print two poles and you can see how well you've got your stringing under control. But the advantage with it is faster print speeds. Like you can print faster, which may or may not matter to you if you're doing it as a hobby. But anyway, but if it doesn't matter, you're probably just going to put up with the stringing anyway. Okay. So print beds, there are different styles of surfaces that you can print on. The idea with your print bed is there's a lot of motion going on while your part is printing. You need to make sure that it stays on your print bed. Some of the common ones are just putting painter's tape on it has a really good surface for that. This will work well for, by itself, glass and painter's tape will work well for, well, not glass, but painter's tape will work well for PLA, which will cover the materials in a bit, but not any of the other materials really well. Glass in conjunction with a heated bed, which is the board underneath it, does work well for PLA as well. Also, something that I do, like I also will put a little bit of glue, PVA, on the bottom, and that will, for prints that just aren't sticking, I put glue on, which creates the same rough surface that allows it to just stick to the bed. The other kinds are removable print beds, which can be also coated. They're generally coated with things, but most people like them. I feel like they're for the impatient because you can take your print off while it's still hot and just pop it off without having to get a scraper or something else. The control boards. The classic combo is to have an Arduino Mega 2560. I think I got the numbers right. I might have gotten the 5 and the 6 backwards. And a ramps board. The ramps board just plugs into your Arduino board. Most kit printers don't actually need most kit printers actually come with an all-in-one board where they combine the Arduino controller chip with the plugs for everything else. This is not quite sufficient. You also need to have stepper drivers. Your stepper drivers tell your motors how much to move, how far to move, and things like that. And they're adjustable. When adjusting these things, depending on your printer, you can run them without active cooling. Sometimes you need it. The slide I skipped over is the firmware. That's just your program that runs the program on your Arduino that tells it how to run. There are other accessories you can get. Most people, and by the way, this is probably a question that you probably should have if you don't already, is how you start your print and things. You can get an LCD screen and with a knob and plug it in and program that with your main board. That will work. You can also just plug in a USB to your Arduino and plug it into your computer and use a controller interface on your computer. The advantage of having an LCD screen that's separate and an SD card is you don't have to have your computer plugged into it. So if your computer dies, your print stays alive. But if your computer dies for an unknown reason, chances are your printer's in a bad position too. But you also don't have to tie it up. So if you're using a laptop, that's nice.
Do you have any suggestions on what you could use software-wise on your computer?
Really, yes and no. There are plenty out there. One of the most common ones is called Pronterface. The one that I think is the most convenient, though, is actually getting a Raspberry Pi dedicated to your 3D printer and installing it's either called Octoprint on it. There's a distro called OctoPi that has it pre-installed. And that gives you a web interface. You can plug in a camera to it and have monitoring capabilities throughout your house. I don't recommend putting it on the internet. It's not built for that really well. Unless you're a security guru and you know what you're doing, keep your 3D printer that could burn your house down off the internet.
How would you even connect it to the internet though? Do they have Wi-Fi cards in them?
Well, if you use a Raspberry Pi,
Oh yeah.
yeah, that one has it. Some printers with boards, like the board that we covered is not the only board out there. There are plenty of boards out there. One of them is called the Do-It boards, D-U-E-T. They're a UK-based company or Europe somewhere in that region.
Okay, that's Raspberry Pi's with my lunch, so it's probably okay.
Probably. But it has a Wi-Fi chip built into that, and it's also a 32-bit board. It does not run on the most common firmware, which is Marlin. But I've heard people have really great experiences with it. Their company is growing. So if you're going to do a DIY build, consider a Do-It as well. Let's see. Oh yeah, FDM print materials. So this is just a bunch of information. I tried to put the key in the upper left-hand corner. The things about materials, apparently from what someone else was saying, glass transition temperature is kind of fake, but it's still a useful measurement, so we're using it. That's the point where your print will start to become all wobbly again. So these prints that I brought for show and tell, they are all made out of PLA, polylactic acid, which is a plant-based print. If you wanted to and you had a high heat composing environment, you could decompose these naturally. But without high heat, they don't decompose well, so it's still kind of a problem. But anyway, the PLA, if you leave it in your car on a hot day, it will melt. Well, not melt, it'll deform. However, PLA also has this really interesting property, a lot of them anyway, where if you leave them at the right heat for long enough, they will anneal, and you don't have to, and they will become heat resistant, which is really cool. So there's like this kind of PLA called high temperature PLA that is specifically made for that, and you can print heat resistant and very strong materials with it. One of the other things about PLA that you'll run into, like the octopuses, they're glow in the dark. The glow-in-the-dark filament is actually an abrasive material. Going back to the Hotend, the extruder part, the nozzles are made of various materials. The most common is brass. You should not print glow-in-the-dark or any abrasive material with a brass nozzle, because the diameter of the nozzle will change very quickly. What you do with abrasive materials is you get a hardened steel nozzle or a ruby tipped. They have those. I don't have one, but you need something that's more resistant to wear, and those ones will, not change while you print. Of the two of the other ones, ABS. ABS, its main disadvantage is, all of these. When you print, sometimes you'll get a smell. PLA has a sweet smell, being plant-based and sugar-based. ABS is acrid, and most people agree that it's probably not good for you. There's another material that I put PLA twice. What did I do? Am I dumb? One of those was supposed to be PET, which kind of has the best of both worlds. Its glass transition temperature is not as high as ABS, but it's still high enough that it's useful for working parts. It also doesn't have the same acrid fumes.
Isn't that the plastic that things like drink bottles are printed out of and stuff?
Yeah, it is actually. I don't know how easy it would be to turn your old drink bottles into it, but it's the same stuff most of the time. But there are also many kinds of PET. Amazon, the print temperatures, however, for PET are a little higher. Usually than even ABS. Some PETs are low enough that you can still do it on a regular printer. But anyway, before getting into how to print, one thing that I mentioned but I didn't really go into detail of, the Hotend that you're forcing your material through, in general, they're lined with a PTFE, which has an acronym that I don't remember what it stands for. But it's sort of like how Teflon, it's non-stick. The main reason for that is if you have imperfections in how your hot end and your heater block and everything was drilled, your material will stick to those imperfections. It needs to be super clean. But with PTFE going in there, it doesn't have to be as well machined, and it can get through. The downside of using PTFE is once you get to about 240 or 250 degrees Celsius, it will start to decay and degrade and do nasty things from what I understand. I haven't tried this and I don't plan to. There are companies that make all metal hot ends that are machined very well, and those can print as high of temperatures as like 300 degrees Celsius before the aluminum starts to melt. And anyway, so the basic process for your 3D printing is you either create your 3D model or download one from Thingiverse, which is most of these. I didn't design any of these ones. These are all, other people designed them, I printed them, because good practice. In general, you run that model through a slicer. Slicer, the name of it is actually pretty spot on. You take your 3D model and slice it into a bunch of 2D models so that it gives the instructions. It'll generate a code called G-code that will tell your printer, okay, heat up, it's like assembly if you're familiar with that, but it's like assembly-like instructions for your 3D printer. Okay, heat up the nozzle. Okay, move it this far. Okay, move it again. Extrude this while you move. And just all these fine details. That's what the slicer does, so you don't have to do that. My grandfather-in-law, he has a CNC machine. He writes his own G-code with programs to make really cool shapes. That would be pretty difficult for 3D printers, and that's why we have slicers. But yeah, preheat. When you preheat your 3D printer, you make sure it's level, your bed. You need a gap, usually about, the way people rate it typically is you have a plain sheet of printer paper, and you want your nozzle close enough to your print bed that it drags slightly underneath it. Or maybe a lot, I don't know. I've gotten that one pretty well, but usually I err on the side of probably a little too close. Danger of getting that wrong, you don't get a first layer because it's touching, or it doesn't stick because it's too far away. While 3D printing with this technology, by the way, the first layer of your print, getting it level, getting that first layer 100% correct, will make the biggest difference of your prints. So spend time figuring out your first layer. If it's not going good, then you can stop it soon. Get that first layer right, and it'll dramatically increase the chance of your print not sucking. Anyway, then however you want to put it on the printer, put it there, watch your first layer. And when I first got my printer and I started working for reals, I spent it might just be because I'm dumb or because I got a kit that wasn't well supported, but I spent 20 hours putting it together. And then once I started printing, I watched the first print just go from beginning to completion. Kind of like watching paint dry, but it was amazing. It's like I put something together and it's moving. And anyway, so here are some common slicers. My current favorite is Cura. These are slicers if you want them. Cura is made by a company called Ultimaker. They produce a 3D printer, but it is not in the below $1,000 price range. But their software is open source and works for all printers. It's great. And now for the recommendation portion of the show of 3D printers. So I went through and I selected a cheap printer and then a more expensive printer, both sub $1,000 because that's important to me. There are plenty of other printers out there. So if you're going to get into 3D printing, it's okay to spend some time doing more research. But the first one is the Ender 3. This one is because it's probably the most common. It's made by a company called Creality. They're a China-based manufacturing company. And their product works really well out of the gate. It's not perfect, but it also has improvement potential. The main flaw that I can think of off the top of my head, though, is they on the original Ender 3, not the Ender 3 Pro, their fan duct is facing up. And if you have 3D printing materials, they might fall into your fan duct. However, you can print a fan duct guard and put it over it and screw it in. There are holes that you can do for that. So anyway, you can make it better. It has a wide community base. Lots of people are supporting this printer. This is if you don't need tech support or don't want it, this is a good, it's like the Linux of 3D printing, I guess, the cheap ones, where you typically don't get your own tech support. The main cons is the firmware is not up to date. This is a really good, another PA announcement for safety. Your control board, Marlin in particular, has a few different heating safety precautions. A min temp warning, a max temp warning, and thermal runaway protection. Max temp means, did it get too hot? And min temp means, is your temperature sensor even plugged in? If your temperature sensor is not plugged in, it will read at a certain value and just shut it off. Thermal runaway, and Creality has those two enabled. The third one is called thermal runaway protection, and as you'll see, the name is very aptly named. Let's say you have let's say while you're putting your kit together, you have your print bed and your print head, and you accidentally plug one thermistor into the other one. When you turn on your hot end, it will read the temperature of your print bed, which is much lower, and just tell your hot end, you're not hot enough, get hotter. You're not hot enough, get hotter. You're not hot enough, get hotter, until your house burns down, or until it just melts and it happens safely. So their boards do not come with thermal runaway protection enabled by default. They do sell an upgrade board just recently that they claim has it, but there's a guy who, his YouTube channel is called, I think, Teaching Tech or something. He went through and showed and proved that even though it did say their thermal runaway protection triggered, it did not actually stop putting power into the heater block. So, which is bad. So with this printer, probably the main thing you want to do first is to upgrade to the mainline open source Marlin firmware. There are dozens of guides on YouTube on how to do this, but the main idea is you need to flash a bootloader, which requires an Arduino Uno compatible board. And you can get a kit for like less than $20 to do that if you go this route. They do have an Ender 5, which has some the Ender 3 Pro has some improvements over the frame and the base model, but it still uses the same board. It's like $20 more. It may also be worth it. But the main advantages with the upgraded version of this is you still have the same community support, same basic frame, but the frame is a little bit sturdier, and I don't remember all the other improvements. Oh yeah, the fan duct. They flipped it so that it faces down towards the ground. And then the expensive printer, the Prusa i3, the guy who made the i3 design. You buy it, you get, there is still a wide community base. You get good technical support, like he hires staff to answer questions. And you get all the bells and whistles of 3D printers. Like this one comes with a removable print bed. It has still has the same sturdy design. It has some custom features like collision detection. One thing that happens to your prints as they go, especially if you don't have good enough cooling, is your prints will warp. Like the layer will warp up, which can sometimes cause, okay, it warps up, now it cools down, the print head comes back, smacks into it, and then all of a sudden your print is skewed. This one comes with this one has a feature where it will detect that, reset itself, and try and resume printing. Like this one has all the bells and whistles you can get for under that price point. And let's see, there was one more printer plan I had a suggestion for, which is the DIY route. If you're really confident in your electronics abilities, in your machining abilities, and all that stuff, the RepRap Way. There are people who've taken the Prusa i3 genuine design and tried to clone it. Like this one guy took a saw and just cut his frame using a steady hand and a keen eye. And got his printer working that well. Those two are a couple YouTubers who have done it, and they've posted their build logs online. Anyway, there are plenty of plans you can go. The sky's the limit. You can get exactly what you want. Like all the features of Prusa's printer, he open sources everything, including all the collision detection. That's in mainline Marlin firmware now. But you can, anyway, yeah, you can do whatever you want. You can build it however you want. People who like the Hing printer, you could make a printer that prints from the ceiling. So good. And then, as I'm not quite out of time, bonus. There are some 3D modeling softwares that if you want to make your own designs, all you really need is a 3D modeler that can produce an STL file, which I think stands for stereolithograph, blah, 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 something. This is the one I like, and I figured many of you would probably be programmers, or at least familiar with programmers. This is my favorite. Its release, if you look in the bottom right corner, says 2015. Don't let that fool you. It is still under active development. They are currently trying to make a 2019 release. And anyway, the basics of how it works, you just express your shapes in a language. Like, you take your cube, subtract another cube from it. Hey, you've got a box. You know, and you can, it works really well for functional prints and designs that you may change and tweak later. Also, I said it's not great for organic prints. I would really love to be proven wrong on that, because I love being proved wrong, actually, strangely, on a lot of things. And then ones I don't use. Everything else is an honorable mention. Probably the most popular one is Fusion 360. It runs in your browser. It's not open source, but it runs in your browser. And by the way, I did not mention that the Windows 3D modeling tool, whatever it's called, I'm pretty sure that's not open source too, but I didn't note it, so I feel like I should say it. And I think that's it. Good luck, have fun. Oh, yes?
Is there any filament material that you recommend that is UV resistant for the outdoor window?
ABS and PLA are both, not PLA, PETG. ABS and PET or PETG, whatever it's called. Those two are good for outdoor stuff. PLA is not very UV resistant. It will break down in the sun.
If you live in an area where like the ground tends to shake frequently, what recommendations do you have?
I would recommend some keen engineering and making it so that your printer doesn't shake with the ground. Like, I don't know, some people put dampeners. Rubber mat, you could do that, but there are prints out there for like your printers called feet dampeners. You just put them on the feet of your printer, and it's supposed to help mitigate the vibrations in it. So whatever you can do, there will be plenty of suggestions dependent for specific printer models, whatever you get to.
Depending on how much ground vibration we're talking about, you could theoretically suspend the entire setup from point at the ceiling, and then any amount of movement is going to be pretty much consistent across the entire 3D printer.
All right.
Yeah. Here's something before I do let you go. There are people who make carbon fiber PLA filament. So you can print using carbon fiber. You don't get the UV resistance because it's PLA, but you can print with some pretty cool materials. There's even a wood one, which when it's going through, I have one. It smells kind of like sawdust or cardboard, one of the two, but it's still really cool. That kind of PLA with wood, you can't really sand it with like a belt sander, but it responds well to like hand sanding and painting.
Is that highly abrasive, like the glow in the dark?
No, but it is heavy in particles, which you should have a wider nozzle than normal. I think the minimum recommendation I've seen is 0.5. That's the one, 0.5 millimeters in diameter nozzle for wood prints. I print mine at 0.4 with just fine, but the minimum recommendation is a little higher.
Are some of those materials more expensive than the others?
Some are.
Like carbon fiber,
Yeah.
So that sounds expensive.
Most of these you can get 1 kilogram for at least $30, depending on where you go. The highest I've seen for most of these is on average about 50, but the brand of PLA I print with is it costs $16 on Amazon, so you can get free shipping with it and stuff if you have Amazon Prime, or if you just buy 2 of them.
What brand do you like?
The one I use is called Inland.
Okay.
It's the, forgot,
Hatchbox pretty successfully?
I've heard of,
The others I've been burned by, so.
so Hatchbox, my first printer, when I was looking into 3D printing filament, I wanted to get Hatchbox, but they were consistently sold out when I was there. So I went with the cheaper one and thought, well, I'll try it.
So you've had good luck then with inline then?
Inland, yeah. It's the current minimum print temps, I think, are about 215 Celsius, but works great for me. I mean, I also don't necessarily have the highest standards, so yeah. Then, yeah, is that?
What would you estimate is the print cost for the materials on the table? Just
Oh,
roughly.
I actually estimated the octopus, and that one's like less than 20 cents.
Okay.
I don't remember. It might have been 7 cents, but I know it was less than 20.
Awesome.
Like,
Depending on how much you spent on your filament and a lot of slicers like Cura, it'll tell you when it slices the model how much it's gonna cost with your settings.
I just weigh my prints after they're done on a small food scale.
Yeah.
And you can also adjust that. Like if you look at the octopus, they print hollow. You just have to print a certain amount of support material on the inside.
Right.
And so they're really light.
So on like how big your model is as far as width, is that depending on your base? Like,
Yeah, well, you mean like how big can you print, or?
like
How big a thing you could.
yeah, like how big of a
That is entirely dependent on your printer and its capabilities. Like the Prusa has like 250 almost, 220 millimeters by like 200. Mine has like 180 by 180 by 180. But then there are other printers, like one other honorable mention of a printer that the next printer I'm planning on getting is the Creality Ender 5, because I'm comfortable doing all the upgrades. But it's that cube design, and that has a 300 by 300 by 300 millimeter build volume. And then there are people who make their own printers. Like there's this guy he calls it the Cosplay 600 because it has a 600, its width is 600 millimeters. And he can print like full cosplay parts with it. And it's, oh yeah, and it's just really cool.
I got a question for you.
Yeah?
How do you handle when your spool starts running out at the very end?
So that depends on what you do, on what you have. Some people will just watch their prints, and if your firmware has a pause print feature, you can pause and then switch out if you're watching it closely. Some people will also put a limit switch and wire that up to their board, so that once the filament is gone from it, it will just stop printing and go into an auto mode where it will take care of that, where it stops it for you so you don't have to watch it as closely, and then put more in. Yeah, so there are at least a couple ways of doing that. Some people will even intentionally do that to print different colors halfway through.
Is this presentation available online?
Yes, I put it on my personal website, and I've been tweaking these slides, but I have uploaded the most recent one. It has my other presentation, which was about AngularJS. Those slides are not as good or as complete as these. And they have nothing to do with 3D printing. But yeah, that's my contact me stuff. And yeah, any questions? More?
So are there any reusable filaments? I saw this really bizarre but interesting video on a Japanese gal that makes molds out of gallium, and I was wondering if they have like gallium filament or...
I'm not sure, but you can look and find there are lots of different kinds of filament out there. And as far as filament reuse, like let's say you have an old print that didn't work out, that is something that there is still being worked on. There is a company that's tried to make it so a filament recreator thing, but it doesn't work that well from all the reviews I've read.
And they're still pretty expensive too, from what
Yeah, they were like, I think the cheapest I saw was like $700. And you could. Anyways, that was.
What are the cleaning considerations, like the print head between print
cleaning. Oh, well, printhead considerations. If you're going to change materials, or even if you're not, you heat up your material to the, okay, two scenarios. If you're switching filament, generally you don't need to clean it. But the way that people remove their filament, if you're going to between prints, is you heat up the nozzle, shove all the molten plastic as quickly as you can out, and pull it out as quickly as you can after that. In general, you don't have to worry too much about cleaning. If you're going to switch from a low temperature material to a high temperature material, or vice versa, you need to have it up to the temperature of the higher printing material, so you can force the old gunk out. And you can just force it by hand, hold down the extruder thing and push.
Like a stick or something, or some plastic?
Just using filament, the filament itself. Yeah. And it does, but if you're printing materials like that gnome, I wasn't confident enough to try and print it without support material. So I printed extra material just to get my main print so it didn't look awful. But yeah, there's always just a little bit of waste. Oh, and as far as costs go, those other 3D printing technologies, resin is more expensive than filament these days. The powder is also more expensive and also has really low reuse. You have to use at least 50% or 60%, something like that, new powder in the sinter, the SLS printing. If I remember right. I could be wrong. But anyway, any more questions?
Not a question, but a point of interest.
Yeah.
SLS is also capable of working with powdered metals, and it's
Oh.
actually the technique that is being considered for creating a moon base by sintering moon dust into structures.
That's pretty cool. That also reminds me of something. Somebody has had a highly abrasive filament. You can get metal filaments and then buy the little oven that comes with it and have like a 90% metal filament print, put it in the oven, burn away all the plastic, and you have your own metal print. People have done some pretty weird stuff. But I guess with that, thank you all for coming.
Thank you.
And just in case, these are some people on YouTube I follow.